Today, we talk about reduce, the most powerful and the hardest of all array methods. Let's cut some pizza. JavaScript is a language.
Don't be scared of JavaScript.
JavaScript is very flexible.
JavaScript is your friend.
It's not magic.
Don't be scared of JavaScript.
A bit complicated, quite a bit complicated.
Next time we'll start making it a bit prettier.
So, let's cut some pizza. Let's say that we have an array of random numbers. So 1, 54, 189, 28, 34, 50. I want the sum of each of those numbers. And of course I can do it in a horrible way. So I can say that let total equals 0. And then I can say array.forEach, take the current element and do total plus equal the element. And let's console.log total. So it does work. The thing is, JavaScript is a language, and like every language, if I use the specific word, it's easier for someone reading the code to understand what's going on. Reduce is made to say that I'm taking an array and I'm reducing it to something else. So when I see a reduce, it's very clear to me that the objective is to extract a compound information from an array. If I see a for each, I have no idea what's going on. So let's move this to reduce. And I know if you're not used, it would be worse. So total is equals to the array dot reduce. Now this function will have two parameters. The first one is the accumulator, which in this case I will call total, but in the documentation it will always be referred as accumulator, even if this one says previous value, which I think is a bit more confusing, and the current element. Now the total is the accumulator of the total. So what I want to do is total plus equal the element. So I'm adding to it. And then I need to return for the next interaction. So return total. When I do plus equal like this, it is summing up. So let's say console log of total, and let's run it. And it still works. It's incredible that I found 2000. I found a multiple of 2 just at random numbers. I will never be this lucky. So the total is working. What you will do more often is, I don't need to reassign total because the accumulator is the interaction of the cycle. So I can just return total plus CL without modifying total because total is just a parameter, it doesn't matter. So I can write it in this way and it still works, which again, it means I can do a shorter function, everything is fine. The other case is sometimes I need to declare what is the original value of total. And I can do that by adding a second parameter here and say it will start from 0. Because it's 0 and because they are all numbers, it doesn't matter. But let's show a slightly more complicated example. I have an array of pizza, and the question I want to answer is, how much would it cost if I would order one on each of them? Let's try to do what we did before. So we do pizza.reduce, and we say total and pizza. In this case, I don't call it element, I call it pizza because it's a single pizza. And I say return total plus pizza.price. I would expect to work as before, but it will not. Now let's assign this all pizzas price, and let's console log all pizza price. So that's what is coming out from. Object 12.9914.y. That's not super simple to understand. So reduce works like this. If I don't give an original value, it will take the first 2 elements. And what it's saying is take total, but total is the first element, and add the price of the second. Now the problem is the price of the second is $12.99, which is here, but the first one is casted to a plus. And when you do a plus like this, it's cast to string. So total as a string, so the first pizza as a string is object, plus the pizza price. It will be casted as string because I'm adding a string to it, and it will show $12.99. And then on the next interaction, I will have object $12.99 plus the price of the third pizza. So I will add another string because it was a string. So as you can see, in this case, not adding an original value makes a huge difference because, well, it's an object. I cannot extract price from total every time because total will not have dot price every time, but I need it the first time. So the easiest is you add the original value here, as we saw before, and now the total will start from 0 and pizza will always be a pizza. So if I do this, everything will work as expected. Except any operation with floating points in any language will cause this weird scenario in which you have this never-ending 9. But maybe I will do a lesson just on that. It is not a mistake, it is how it works. There is a big int library if you need to work with arbitrary size, and you can always convert everything as big int by multiplying before doing the operation and divide again after. Generally, is not a big issue because this is clearly 71 and 95. Let's verify, just out of curiosity, if that's true. So if I want to know that, I just have to multiply every time by 100, so they are not floating numbers anymore, and then I just divide by 100 here, and it's 71.95. So I wouldn't say it's a big deal, but if it's a big deal for you, you always have to convert to full number. That's also the reason why in every actual economic JavaScript implication, you pass everything as a string and you use a library like BigInt to make the operation. BigInt also works with floating, while the JavaScript BigInt implementation only works with integer. But we will leave this for another day. I hope I gave you an idea about why reduce is used. And as usual, remember that JavaScript is a language, so it's very important that we use reduce when we want to express that we want to reduce the values. And now it's your time to cut some pizza.